What we are talking about today is a little bit more simplifying radicals, going a little bit more in depth. So let's start off by doing a review of simplifying radicals. All right. So we start off with, and let me see if I can find which one it is. Yep. 5 square root of 4. Okay. 5 square roots of 4. That's the same thing as 10. How do I know that? Because the square root of 4 is 2, and that equals 10. All right, but today we're going to talk about adding and subtracting radicals. And so I'm talking about stuff like what I have here in my problems here. Notice what I have written down. Adding and subtracting. In order to add and subtract, you must have the same index. Remember what the index is. That's the number where the square root is. In this case, the index is 2 for both of those. On all these examples, you got a square root or the index is 2. But remember, an index is the number outside the radical. Okay? So whatever the index is, they have to be the same in order to add or subtract. Radicals must have the same stuff. I just said stuff, but that means numbers and variables underneath the radical. All right. Now, if you got 1 and 2 done, or they're okay, then you simplify any radical that you can, if the radical can simplify, like what I did here at the beginning. And then you add or subtract the coefficients of the radicals with the same stuff underneath. But you do not add or subtract the numbers underneath the radical. So, for example, number 1 should equal -7 radical 17. I didn't say 17 plus 17 and 34 or multiply those or anything. This is like -3x minus 4x, which would equal -7x. You don't say x squared here. If they have the same variable in the same exponent, you can combine or add or subtract, which is what that means. Same thing goes for the radical. Basically, the same number underneath the radical is like your same variable. So as long as you have the same number underneath the radical and the same index, you can add or subtract the coefficients. Hopefully what I just said you listened to. Look at number 2. I cannot right now. That's a 3. That's a 27. So I can't say -2 plus 3. However, I can look to simplify this. And you need to go back to your notes and stuff if you have a hard time with this. But this is going to simplify as 3 times 3 radical 3. Which that becomes 9 radical 3. And I bring 2 radical 3 down. And now look, I can actually combine those to get 7 radical 3. Alright. Now, square root of 27 to 3 radical 3. If you have a hard time with that, you need to come see me so we can talk about it. Number 3, I cannot say 2 minus 2 because those 6 and 24 are not the same. This does not reduce. Neither did the -2 radical 3. However, 24, square root of 24 does. So it'll be -2 times 2 radical 6. Again, how did I go from here to here? You need to see the previous notes. Talk about it in class. That becomes -4 square root of 6. And I bring my 2 radical 6 down because I didn't do anything with that. I just simplified all this first. Once I did, notice I got the same number underneath the radical, same index. So that becomes -2 square root of 6, not -2 square root of 12. Number 4, just want to show you different types of examples. Not the same number underneath the radical, but -12 becomes -2 square root of 3 plus 3 radical 3. How did I go from here to here? See previous notes. But when you do this, it becomes square root of 3. If you write 1 in my book, that's not wrong. Some teachers don't like that, but I'm okay with it. So that's how you add or subtract fractions. Radicals. You add or subtract a number in front, called the coefficient. You do not add or subtract the variable. It's just like having an x or y. We just talked about adding and subtracting. Now let's talk about multiplying radicals. It's very simple. As long as they have the same index, you can multiply the numbers underneath the radical. You never multiply a number outside of the radical by a number underneath the radical. So if it's a whole number, you cannot multiply it by a number underneath the radical. So these two numbers are numbers underneath the radical. That becomes the square root of 24. The square root of 24 reduces down to 2 radical 6. Again, check that out if you don't know what happened there. But I can multiply those two. Now, this is a distributive property, and I know it's distributive property because I have a sign in between. There was no sign, no plus or minus or anything. The number outside parentheses. So you got all the makings of distributive property. That's fine. I can take those two and get the square root of 30. When I multiply those two, I can because they are the same index and the same radical. Notice this becomes 9 square root of 5. See, the 9 is not underneath the square root, so I couldn't say that's 45. Okay, so don't get confused there, because a lot of people mess up thinking that it's just always multiply the numbers underneath the radical. That's a whole number, so it goes out in front. It's like 9 times x. And you would try to simplify this, but square root of 30 doesn't. I can't remember if they make you switch it around like this. I don't know. Either way, those are cool. But if you look at number 3, notice that number 3 is a FOIL. How do I know FOIL? I got 2 terms and 2 parentheses. So that means square root of 2 times both of those, distributive property. Square root of 3 times both of those. So let's do that. Square root of 2 times square root of 7 is the square root of 14. Square root of 2 times negative square root of 5 is negative square root of 10. So what did I do? I did this times both of those. Now I'm going to do these two times each other, which is plus square root of 21. Remember, the signs go outside the radical, not underneath the radical. And then you get minus the square root of 15. Now you would look to simplify each one of those, but none of these simplify. If anything could add or subtract, you would look to add or subtract if they had the same number underneath the radical. But none of these can simplify, and nor can you add or subtract any of it. So that's as far as you can go. Now there'll be more different problems on stuff like that where you can. I just want you to see the basics. That all the previous multiplications that we've done, you can do with a radical. You just need to know how to do it. Numbers underneath the radical times numbers underneath the radical. Numbers that aren't underneath the radical, you can't do that, and that's the bell. And so I gotta pause. Alright, now let's talk about when you divide. Here's some information you want to get down, just like the rest of the stuff in these notes. Never leave a radical in the denominator of a fraction. So now let's talk about how to remove radicals from the denominator. Multiply the whole fraction by the radical in the denominator only when there is only one term in the denominator. So here's your 2 steps right here. If there is one term, multiply the whole fraction, numerator and denominator, by the radical in the denominator. If there are 2 terms in the denominator, then multiply the whole fraction, that means numerator and denominator, by the conjugate of the denominator. And so here I'll talk about the conjugate. The conjugate is the same terms, but change the middle sign or the second sign. So here's an example. The conjugate of 5x minus 4 is 5x, that should be plus 4. That should be 5x plus 4. And the conjugate of negative 2 radical 3, negative 2 square root of 5 plus 3 is negative 2 square root of 5 minus 3. Notice the negative 2 square root of 5 stays the same. You don't mess with the sign of the first term. It's always the middle or the second sign. Alright, so let's look at number 20 here. Number 2. We have, where we at? This. Alright. Square root of 15 over 5 radical 2. Now, I could do, since it's only one term down here, this is what I want to do. I could do square root of 20 over square root of 20. I'm going to go ahead and simplify this. Square root of 15 over 10 radical 5. Okay. Oh, now what happened there? This 5 times the square root of 20. The square root of 20 becomes 2 radical 5. So 5 times 2 is 10. Alright? So now instead of doing square root of 20 over square root of 20, what I'm going to do is the square root of 5 over the square root of 5. And I'm going to multiply this just by the radical. Notice I didn't say 10 radical 5. You only multiply your numerator and denominator by the radical. That's what this is saying. You multiply by the radical in the denominator, okay? So you multiply the radical by the radical. The only radical down here is the square root of 5. So this becomes, what is that, 75? 15 times 5? Yeah, that's square root of 75 over 50. Now let's talk about that real quick. Square root of 15 times square root of 5, because you multiply straight across, gave me the square root of 75. 10 times square root of 25. It's 5 times square root of 5 times square root of 5 is 25, which is really 10 times 5, and that's how I got that 50 there. However, this is not my answer, because I can simplify the square root of 25. That actually equals 5 radical 3. Now, if you want to know how to do that, look at the previous notes. So I have 5 radical 3 over 50, which my final answer turns out to be square root of 3 over 10. Now, you want to know a shortcut? What is the square root of 15 divided by the square root of 5? See, since they're both the square root, 5 going to 15 3 times, so I could have had the square root of 3 over the square root of 10 right there. It all depends on how you look at it, but you still get the same answer there. I just took it step by step so you can see which one. Let's look at the second problem here. I have radicals in the denominator. The first thing I'm going to do is multiply by square root of 5xy cubed over the square root of 5xy cubed. Why? Because I can't have a radical in the denominator. And so when I do that, I'm going to get, separating this, I'm going to get square root of 15 x cubed y to the 6 over 4 times 5xy cubed. Now, what you got to remember is this. Anytime you multiply a radical square root by another square root, your answer is going to be the square root. Well, I mean, what's underneath the square root. So 5xy cubed times the square root of 5xy cubed, that drops out, and so it's really just 4 times 5xy cubed. Alright? So for the sake of speeding up, let me go ahead and work this out. Alright, so as I simplified this line to this line, and this line to this line, from here to here I reduced. I divided out the like term, the common factors here. The x's canceled out, the y cubes canceled out, and so I got that right there. As one, notice I got 2 terms here. In the previous problems, there was only one number. Even though it was several stuff underneath the radical, it's only one whole thing. There's no plus or minuses. It's all one. But notice on this one here, it's right here, you got 2 terms. So here, I can't just do by square root of 5 over square root of 5. I have to use what's called the conjugate, which is 4 minus 4 radical 5. That's the conjugate, what I talked about earlier. I only use it because I got 2 terms here. So please remember the difference in the 2 terms. Now, this is the distributive property. So let me do that. 3 times both of those gave me that right there. Now, the bottom is a FOIL, but you don't have to actually FOIL when you have a conjugate times the original. You only have to multiply the first 2 and the last 2, because the 2 middle ones are going to subtract out. That's the whole reason why. Alright, I went ahead and worked out the rest of the problem for the sake of time. When I did the FOIL here, I didn't do the middle 2. I just did the first 2, 16. The last 2, negative 16 and square root of 25. But the square root of 25 actually equals 5 without the radical. And so when you do 16 minus 16 times 5, you get negative 64. And there goes the other bell. And so the rest of this is just simplification. Simplified each one of those, divided them by 4. And sometimes your answer is written in either one of these versions. Okay, I wish I could have done more. We'll do more in class, but this is the general way of rationalizing the denominator. Multiply by the conjugate.